Let's look at this one. Tom and Larry move from two places towards each other. Tom moves at the speed of 70 meters per minute, and Larry moves at the speed of 50 meters per minute. If no one ever stops, they will meet 100 meters away from the middle point of the path. If Tom stops for a while, they will meet 250 meters away from the middle point of the path. How long has Tom stopped? Well, it sounds like a complicated problem. In this problem, we can see that there are two cases. In the first case, no one ever stops. In the second case, Tom stops for a while. Okay, to make things easier, let's draw a graph to compare the two cases. Now, if I draw a line to represent the path between the two places. So this is Tom. I use the initial letter T to represent Tom. And this is Larry. I use L to represent Larry. In the first case, no one ever stops. They meet 100 meters away from the middle point of the path. So the middle point is here. And this is point A. This is point B. The problem only tells us they will meet 100 meters away from the middle point of the path. However, it doesn't tell us on which side of the middle point they meet, right? So they could meet here. And let's call this point M1. So this is 100 meters away from point M. Or alternatively, they could meet here. Let's call this M2. M2 is also 100 meters away from the middle point M. Abby, do you think they meet at M1 or M2?
I think they should meet at point M2. Because Tom is faster?
Very good. Because Tom is faster. For the same amount of time, Tom must have traveled more distance than Larry, right? So it must be M2. Let me erase M1. Okay, when they meet at M2, what is the distance traveled by Tom? From which point to which point?
Point A to point M2.
Very good. And how about the distance traveled by Larry?
From B to M2.
Okay, very good. So from A to M2 is the distance traveled by Tom, and from M2 to B is the distance traveled by Larry. Okay, now we know Tom had traveled more distance than Larry. But how much more distance did Tom travel? Can we find that?
I think it's 200 meters.
Oh, really? Why is 200 meters? The point they meet is 100 meters to the right of the middle point. Why Tom had traveled 200 more meters?
Because Tom traveled 100 meters more than half the path length, Larry traveled 100 meters less than half the path length.
Fantastic. A lot of people made mistakes here. The distance Tom had traveled is from A to M2, which is half the path length plus 100. And the distance Larry traveled is from B to M2. It is half minus 100. So one distance is half plus 100. One distance is half minus 100. The difference between the two distances is 200, not 100. Okay, cool. Now we know Tom had traveled 200 more meters than Larry for the same amount of time. And we also know the two persons' speed. Abby, what do you think we can find based on these facts? So we have learned meet problem, and we have also learned chase problem. Do you think this is a meet problem or a chase problem?
It seems like a chase problem, but they move toward each other, so I'm not sure.
Okay, the two persons move towards each other. Typically, when two persons move towards each other, it's a meet problem. When one person chases another person in the same direction, it's a chase problem. But this is not always the case. We should not just memorize these scenarios. We need to grasp the essence. What exactly is a meet problem and what exactly is a chase problem? It's not about the direction. Essentially, it's about what we need to find based on what we already know. Like in this problem, what we know is Tom had traveled 200 meters more, right? 200 meters more distance than Larry. And we also know their speed. Tom traveled 70 meters per minute, and Larry traveled 50 meters per minute. So for every single minute, Tom can travel how many more meters than Larry?
20 meters.
Right. Tom traveled 20 more meters than Larry for every single minute. And in total, Tom had traveled 200 more meters. Then if we divide 200 by 20, we get 10, right? What does this 10 represent?
The time?
Right. So the difference between the distance they have traveled divided by the difference of their speed, we get the time they both spent traveling, right? So it's a chase problem, not a meet problem. Essentially, a chase problem is just when we know how much more distance one person travels than the other person, and we also know the difference of their speed. And then we can find the time they spend traveling. So the direction doesn't really matter. It could be both persons travel the same direction or opposite direction, or even when one person flies into the sky and the other person dives into the ocean. The direction doesn't matter at all. So it's perfectly normal when two persons move towards each other and it's still a chase problem. Now you're clear about it?
Yeah, I got it now.
Fabulous. Now that we have found the time they have spent traveling, which is 10 minutes, what else can we find? Don't forget that we know their speed and the time they spent traveling. So what can we find now?
The total distance.
Fantastic. This process is also a meet problem. They move towards each other. So what is the total distance traveled by them? It's 50 plus 70 times 10, right? We got the total distance is 1,200. And the total distance is just the length of the path between A and B, right? So this is a very important step. Now we got the length of the path. Okay, now we have found out a lot of information from the first case. It's time to move our attention to the second case, if Tom stops for a while, they will meet 250 meters away from the middle point of the path. First of all, let me draw another graph to study what's going on with case 2. Again, I draw a line to represent the path. And this is point A, and this is point B. Now, Tom stops for a while. They meet 250 meters away from the middle point. So this is the middle point. Again, let's call it point M. Like the first case, it doesn't tell us on which side of the middle point they meet. They could meet here is 250 meters away from the middle point, or they could meet here also 250 meters away. Abby, what do you think? On which side they should meet?
I'm not sure.
Okay, think this way. In the first case, Tom never stops. So that means Tom keep going all the time at full speed, and he can only go this far. It's 100 meters more than the middle point. Now, in the second case, he had stopped for a while. That means he should not be able to go this far, right? He should not be able to go this far, right? Suppose they meet 250 meters to the right of the middle point. It would mean that Tom can travel even more distance when he stopped for a while. Is it possible?
No.
It sounds like if you are a student and you study really hard, you end up getting an A for your final exam. But if you don't study that hard, you spend a lot of time playing video games, but you get an A+. Does it make sense?
No.
Similarly, in the second case, it must be that they meet 200 meters to the left of the middle point. So they meet here. Let me erase this side. How about the distance between M and B?
600 meters.
Very good. So from the first case, we already found the length of the path is 1,200 meters. So this is half the length of the path. So it must be 600 meters, right? So then what is the distance between this point to point B?
850.
Very good. So who had traveled this distance?
Larry.
Yeah, it's Larry. So Larry traveled 850 meters. And what about Tom? It should be Tom traveled from A to here, right? So this is traveled by Tom. It's 600 minus 250, right? So it's 350. So this is the distance traveled by Tom. We can see that Tom is faster than Larry, but this time Tom had traveled much less distance than Larry. Why is that?
Because Tom stopped it and Larry didn't.
Yes, right. So it's similar to the turtle rabbit race, right? Tom is faster, but the guy is lazy. He didn't keep going. Then to find out how long he had stopped, what can you do? Let's see what we already know about Tom in the second case. Do we know the distance Tom had traveled?
Yes.
Right. We know that Tom had traveled only 350 meters, and we also know Tom's speed. So we know the distance, we know the speed. Then what can we find?
The time.
Yes, very good. So we can find the time Tom spent traveling. That is 350 divided by 70 equals 5. So Tom spent 5 minutes traveling. And how about Larry? Larry traveled 850 meters and his speed is 50, is 17. So Larry spent 17 minutes traveling. Actually, the two persons start moving at the same time and they meet at the same time. So they should have spent the same amount of time on the way, right? So since Larry had spent 17 minutes, Tom should also spend 17 minutes on his way. However, Tom's time consists of two parts. Part of Tom's time is for traveling, and part of his time is for taking a break. And he spent 17 minutes in total and 5 minutes in traveling. Then what is the time he spent on taking a break?
17 minus 5, which is 12.
Yes, very good. So 17 minus 5, which is 12. Then we finally got the solution to this problem. Tom had stopped for 12 minutes. So let's recap it. What have we learned from this problem? Firstly, the direction does not determine it's a chase problem or a meet problem. What determines it is what you know and what you need to find. When we know the difference of the distances traveled by the two persons and also the difference of their speed, and you need to find the time they spent traveling, it is a chase problem. When you know their speed and the time they spent traveling, and you need to find the total distance traveled by them, it is a meet problem. Secondly, for a multi-step problem, what you have found through previous steps must be kept in mind and used in future steps. Like in this problem, through the first case, we found the length of the path. In the second case, we need to use it as a value we already know. Otherwise, without the length of the path, we cannot proceed to solve the problem. This may sound easy, but it's not that easy if there are a lot of steps. So when you find something you believe is valuable, just write it down in some noticeable place and remind yourself you'll probably need it in the future steps. Okay, thank you for watching. See you next time.